Right, my intention here is to just give a very, very brief introduction to the theory of algebraic equations. Um, as I stressed before, that when you get a solution of these equations, you can check back to see whether you got the right answer, and that can be useful. So, I mean, really, I really need to stress this: is that an equation is just like a set of balance scales. You know, if you know what they are in this digital age. You know, you got balance scales with two pans either side, containing weights, or it could be a certain amount of food or whatever, and they will balance as long as the weights are equal. Now the thing is that if I take a certain amount off one end and a certain amount off the other side, they will still balance. So in that sense, that's exactly the same as what you can do in algebra. You've got an algebraic equation where both sides are equal. If I subtract a number from one side and subtract a number from the other side, that equation will still balance. And I can do more complicated things here. I can, you know, if I multiplied the whatever's on the, if I multiplied that weight by 3 and multiplied that weight by 3, they would still balance. Likewise, I can multiply the left-hand side of the equation by 3, and multiply the right-hand side of the equation by 3, and they'll still balance, and so on and so on. What you need to do when you multiply, though, is you need to multiply everything on the left-hand side and everything on the right-hand side. It is a major error, or a common error, for people who realise the general idea, but then, you know, if they've got two terms on the left-hand side and they know they need to multiply by 3, for example, it's an error for a lot of people. Instead of multiplying both terms on the left-hand side by 3, they'll just multiply one term on the left-hand side by 3, and that won't work, you know. I mean, you think of it in terms of this balance scale. If I've got two food items on there, and I just increase one food item by 3 and leave the other food item unchanged, and I multiply everything on here by 3, then the scales will not balance. So that's just an error to look out for. So again, start off with a very simple one. X plus 3 equals 9. Now, what I need here is, the technique here is to stick the next line underneath and the next line there underneath. I want every separate line under the previous one. And so that means that I want everything that appears on, well, that second line has got to be followed logically from that line. I'm stressing this because, I mean, technically speaking, you could probably do this in your head, but I'm doing it as an algebraic equation to show you the technique. What happens is that some people they go halfway through an algebraic equation and they suddenly realise, okay, I'll just forget about the x and I'll just do some sort of division somewhere. You know, and that's just not allowed. There's an x here, so there's got to be an x on every single line of the equation. Okay, if you have a line of an equation without an x in, then that's wrong. And what else was I going to say? Oh yeah, I was going to say something. I'll leave that till later on. What I was going to say. Now, again, remember what we need at the end of the day. We want to find out what x is. That's the whole sole aim. So basically, I want x equals such and such. So x on the left-hand side, that's okay. That can stay where it is. Okay. I want x equals some number. So x can stay where it is. That's okay. That'll stay where it is on the next one. What I want to do is I want to get rid of this. Okay. There's a number there. That's okay. I can have numbers on the right-hand side. But this number, I want to get rid of it. So how I get rid of it is I subtract 3 from the left-hand side. But having subtracted 3 from the left-hand side, I need to subtract 3 from the right-hand side. I mean, that's a very basic idea, but I just, let it sink in. That you need to do exactly the same things to both sides of the equation. As long as you really ram it into your head that you need to do exactly the same thing to both sides of the equation, then that's the real hard work done. From then on, it's just technique as to how to use that rule to arrive at the answer you need to need to derive. So yeah, do the same thing to both sides of the equation. Subtract 3 equals 9 minus 3. So next line I'll tidy up. So I'll tidy up the left hand side. X stays as it is. 3 times 3, sorry, not 3 times 3. 3 minus 3 is 0, so I can just leave that out. 9 minus 3 is 6. And that's your answer. I've got x equals 6. Stick that back into the original equation. If that's 6, then 6 plus 3 equals 9. That equation is correct, so your answer is correct. You know the answer you've got is correct, so you don't need to leave it to get your paper back or anything. You know straight off that is correct. And if it's not correct, you know to go through the procedure again and hopefully get the right answer. So in this simple introduction, I'll just give one, I'll just give one more example, slightly more complicated. X plus 6 equals x plus 6 equals minus 9 minus x. So remember again what we need. We need at the end of the day, we need x equals such and such. So that x can stay where it is. I want to get rid of that. That number can stay as it is because I'm quite happy to have numbers on the right hand side, but I need to get rid of that. So I'll do it logically. I'll get rid of this first. Use the same technique as I did before by subtracting 6 from both sides. So it's x plus 6 minus 6. And the right hand side is that, but I need to minus the 6 to keep it consistent. So I've subtracted 6 from those sides. Next line I tidy up. So it's x, 6 minus 6 is 0, so I can leave that off. Now here I've got minus 9 minus 6, which is minus 15. And that minus x can stay where it is. Now, that's the next thing. I don't want that there. So that's a minus x. Now I can get rid of that by adding x to both sides, okay? So I need adding x to both sides, so that's x plus x equals minus 15 minus x plus x. So adding x to both sides. Next line, tidy up. So x plus x, remember these are really 1x plus 1x, so that's 2x. Minus 15, that can't be simplified, so that can stay written down again. So we've got minus x plus x, that disappears, that becomes 0. So that's a bit more in the form I would like, x equals such and such, except that I haven't actually got x equals such and such, I've got 2x equals such and such. So how do we get x equals such and such? Well, I divide both sides by 2. So this is where a lot of people have make a bit of a mess of the layout actually. If I'm going to divide that by 2 and do it explicitly, I need to do it on a separate line. 2x times 2 equals minus 15 over 2. Again, this is quite another point that's worth noting, that some people will come along and say, okay, I'll stick the 2 underneath there and start operating on the line that they've derived from the previous line. Now, the problem there is that I want to see it line by line. I want to go from there and realise, go from there, okay, I see what you've done. I see what you've done there, see what you've done there, see what you've done there, see what you've done there. If you start operating on this line, then I come to here and okay, I can't see immediately how I get from there to there. So always start a new operation on a new line, okay? That's a quite important rule in layout. Another one while I'm on the subject is sort of crossing out. People, well, it's like here. Some people will love to cross this out, 2 on top, 2 on the bottom. But that's not necessary because I want to go from here to here. If you're crossing things out, it loses the continuity. I can't see immediately where you've gone from there to there. And there's obviously another aspect that if you're crossing things out, I don't know actually whether you're crossing things out due to cancellation or whether you're crossing things out because it's an error. So I would strongly discourage crossings out, because you should be able to see immediately what you're doing without crossing out. I mean, to cancel this out, you're dividing the top by 2 and the bottom by 2, and that becomes 2x. You're doing decancel the 2's out, so it becomes 2x over 1, which is 2x. So hopefully you can understand why I've just gone to 2x. I mean, the more you get into this, you can understand that anyway. So from my point of view, if I'm another person looking at your work, or even you yourself checking your work half an hour later on, I can see I've gone from there to there, and I should be able to see how you've gone from there to there without you cancelling things out. Okay. So you should have a line of algebra where it's obvious what you've done on one line, how one line has followed from the preceding line. If it's not obvious, then you need to stick in another line to make it obvious. But I would highly recommend you do not cross things out, and you do not operate on lines that you've written already. You always start a new line to do a new operation. And that's really, well, having done that, that is your answer. You know, that's a perfectly acceptable answer, that 15 over 2. You could multiply it down, you could simplify it down to minus 7 over 5. But I can tell you now that you know, in mathematics, that is quite an acceptable answer. Minus 15 over 2. Yeah, while I'm on the topic, if you got it, well, you don't really need a calculator for this, but if you said, okay, that's minus 7.5, that would be an acceptable answer in a way, because that would be exact. Minus 7.5 is exactly equal to 15 over 2. But I mean, if it was minus a third, then if you got a calculator out and put down minus 0.33, then that is not exact. Minus 0.33 is not the same as minus a third. So minus a third would be the exact answer, and you've got your calculator out and put down an approximation. So all that time is wasted. You've got your calculator out and put down an approximation, you know, an answer that is slightly wrong. So you would have been just better going with minus a third. So that's another sort of recommendation. You know, if possible, do not get your calculator out. Remember that quite often, just straightforward fractions, or well, quite often just straightforward fractions are an acceptable answer to a mathematical problem. Anyway, thanks for being with me. You're still here. Cheers for now.